America is now getting so confident about the success of this lunar landing mission that they've just doubled the amount of lunar soil and rock that they expect to bring back. For 2 years now, they've been telling us that 40 or 50 pounds would be the absolute maximum. Now they're hoping for 100 pounds or more, 50 or 60 pounds in each of 2 of these vacuum-sealed boxes. And this is going to be a great relief to the hundreds of scientists all over the world hoping to get a share of these lunar samples. Don Lind, one of the astronauts who's been specializing in lunar activities, has been telling us what's going to happen when Armstrong and Aldrin touch down. This, I gather, is the camera that'll show the whole world Armstrong stepping onto the moon.
That's right. This camera will be mounted in one of the exterior stowage pallets on the lunar module and will be focused at the base of the ladder and will be turned on as he comes down the ladder. So we will see that. Then Neil will remove the camera from that stowage location and set it up on this tripod and set it out further from the lunar module so that we have a rather good picture, we think, of most of the activities. Obviously, the first experiment is the collection of the lunar sample material. And that will be done in 3 sections, and that's the first thing that they will do. The next scientific experiment after the initial sample collection is the solar wind composition experiment, and the foil will be exposed to the solar wind. Now that's the atmosphere of the sun that boils off and streams out through space. Of course, there's no atmosphere on the moon, so it's not a wind as we normally speak of the term. It's a very thin gas, which is very real. We wouldn't feel it. If it were impacting on our skin or something, we wouldn't feel it. But the particle will penetrate into this foil and will become part of the foil. We'll return the foil to Earth, and then as they are able to analyze the foil, we'll get the gases that originally were part of the sun, came to the moon, and became part of the foil. As they proceed around the lunar module, inspecting the exterior of the lunar module, when they get around the back, the 2 large experiments, the passive seismic detector and the laser corner reflector, will be offloaded. The passive seismic experiment is really a seismic laboratory miniaturized into about a 16-inch high can. And we call it passive because there's another experiment for later flights which will actively set off charges and provide seismic noise. But this is a device to listen to the naturally occurring earthquakes, or I guess you should call them moonquakes, or meteors impacting the moon. And this is a device which, of course, will tell us a great deal about the interior of the moon, the same way that seismic stations tell us about the interior of the Earth, that it has a core and a mantle and a crust, these sort of things.
Then I think comes the laser experiment, which not only you can use, I suppose, but the Russians and everybody else.
That's right. This is sort of an international facility we're putting up. It's really a mirror. It's a special kind of a mirror because it reflects light back in exactly the direction from which it arrives. And by bouncing laser signals off the moon, you can very accurately measure the distance to the moon. Now that, of course, is of interest to astronomers, but the moon does funny things. It wobbles back and forth, and we can measure the librations, which tells us about the distribution of mass inside the moon. We could tell if the moon and the Earth are slowly drifting apart, which would tell us something about the general theory of relativity. We can tell, if we range at it from both the North American continent and Europe, we can tell if North America and Europe are drifting apart, check the continental drift theory. So there are a number of things that we can do simply by putting this very sophisticated type mirror on the moon.
Now can I ask you a couple of general questions? When the lunar module actually touches down, Dr. Lind, do you think it's going to blow up a tremendous cloud of dust which may take a long time to settle?
Well, we certainly expect it to blow up some dust. Now, whether this is going to interfere with the landing, we expect not, but we have the capability of aborting in case it should do. There's no indication that it should persist very long. We think if there is any dust cloud at all, it will dissipate very quickly because the dust particles don't billow as they would in the air. They're just like tiny bullets. They follow ballistic trajectories and would fall back very quickly. They're not suspended. They would not tend to float in the air as they do on the Earth.
At what point will they have to decide they've either got to land somewhere else or abort and get back into orbit as quick as they can?
Well, you have a continuous abort capability. In other words, if anything goes wrong, dust or any other kind of problem that could come up, you can always abort in 2 different modes. You can either use the descent stage for the abort, or if that engine's having trouble or something, you can use the ascent stage only. So you have 2 different two different capabilities of aborting, and you have that capability continuously, right, until you mechanically shut down the engine after you've touched the surface. And as long as the engine's running, you have some capability of moving sideways to a different position.
What do you think the chances are? Would you put it 50-50 or less than 50-50 of doing this touchdown successfully?
Now, if you mean successful landing by getting there without endangering the crew, we think it's much, much higher than that. We don't think that the crew will, this is a very tricky part of the mission, obviously, but we think the crew is essentially safe all the time. Whether you mean a successful touchdown so that you can have a chance to get out and pick up rocks, I personally would put it much higher than 50%, but nothing ever gets 100% sure. So, I don't know, I would say just personally, about a 90% chance of a successful touchdown.